Everybody knows that dreams are generated by brainstem during REM sleep and have no emotional or subjective value. Your biology is wrong. Here's a bazinga. Dreaming and REM sleep are controlled by different brain mechanisms, by Mark Solms. Dreams are a peculiar and exciting part of our lives, while the interpretation of their often bizarre and absurd content has become the subject of many speculations and disputes through the centuries. Dreaming is considered of great importance for the health of both the body and the mind, while the average person spends about 2 hours each night in the dream state. In the last few decades, due to the rapid growth of neurosciences, a new approach to the study of dreams has emerged. An approach which asks a seemingly simple question: how do our brains create dreams? Well, the answer might not be so simple. We're all familiar with the position that when someone dreams, they're in the so-called REM sleep state. However, Mark Solms, a prominent neuropsychologist, founder of the Neuropsychoanalytic Association and also a winemaker, provides a considerable amount of evidence to convince us otherwise. But let's start from the beginning. What do we know about sleep? Sleep is usually divided in two distinct phases: rapid eye movement sleep, in short REM, and non-REM sleep. REM sleep occurs in 90 to 100 minute cycles, as you can see here, between 4 non-REM stages, and is accompanied by high brain activity similar to wakefulness, muscular atonia, and of course rapid eye movements. The idea that REM sleep is the physiological equivalent of dreaming came as a reasonable point, since in 70 to 95% of awakenings from the REM state, normal subjects report that they have been dreaming, compared to only 5 to 10% of non-REM sleep. It was that observation that led many to conclude that dreaming is just a subjective byproduct of REM sleep, and so, in order to get the dreaming brain, one had to get the brain in REM state. In this context, two US researchers, McCarley and Hobson, proposed the activation synthesis model in 1977. This model, through many modifications, has dominated the field and remains a prevalent position even today, almost 50 years after its initial proposal. They suggest that dreaming is generated in the brainstem, one of the oldest areas in the evolution of the brain, which also has critical function for an organism's survival, like these ones. And, of course, it also regulates sleep. Well, their main arguments go like this. First, REM sleep, and therefore dreaming, is triggered by special REM-on cells that use acetylcholine in this part of the brainstem, and terminated by inhibitory REM-off cells that use noradrenaline and serotonin here. Following studies reveal that you also dream during non-REM sleep, for example when in sleep onset or in the rising morning phase, so the model changed to include the new data. However, the next two basic premises remain the same. Let's check them out. The second premise is that the causal stimuli for the dreaming process arise from the brainstem, as mentioned earlier, a brain area which is considered to take part in many automatic processes. That means dreaming is not generated in the forebrain, which plays a central role in the processing of information related to complex cognition, sensory and associative functions, and voluntary motor activities. According to Solms, the forebrain in this model is assigned an entirely passive role, trying to make the best possible fit of this intrinsically inchoate brainstem data. Keeping this in mind, here comes the third premise. The dream process is seen as having no primary ideational, volitional or emotional content. In this way, it does the best of a bad job in producing even partially coherent dream imagery from the relatively noisy signals sent up from the brainstem. What is the meaning of this? It is that dreams are random in their content, unrelated to our mental lives, our wishes, our desires, our expectations or fears. Or, in other words, they lack subjective value. Well, Mark Solms could not disagree more. In his landmark paper, Dreaming and REM Sleep are controlled by different brain mechanisms, he proposed that REM is just one of the many pathways that can activate a forebrain common path, with this being actually the mechanism that creates our dreams. To support his point, he provides us with neuroscientific evidence on the ways dream generation can be either terminated or initiated. Let's start with the first category. Solms refers to the 111 published cases in the human neurological literature until the year 2000 in which focal cerebral lesions cause cessation or near cessation of dreaming. In almost all these cases, the lesions were localized to the forebrain, leaving both brainstem and REM sleep completely unaffected. In 94 of these cases, the lesion was situated in the posterior convexity of the hemispheres, in or near the region of the parietotemporo-occipital junction, an area that integrates visual, auditory, and somatosensory information into high-level cognitive functions, therefore playing an important role for mental imagery. Another forebrain area which causes loss of dreaming when damaged, according to Solms, is the white matter surrounding the frontal horns of the lateral ventricles. This region is also the operation site of prefrontal leucotomy, another name for the notorious lobotomy, which leads to no dreaming at all in 70 to 90% of the cases. Some suggest this is because this region contains fibers, which connect frontal and limbic structures with dopaminergic cells in brainstem and other brain areas, shaping the famous signaling system in our brains. In his words, these circuits instigate goal-seeking behaviors and appetitive interactions with the world, while lesions of these areas leave the REM sleep intact. And there are some other relevant facts. Schizophrenia's dreamlike symptoms are thought to be caused by overactivity of this dopaminergic system, while antidopaminergic antipsychotic drugs inhibit excessive and vivid dreaming. Also, chemical activation of this system, like when taking L-DOPA for Parkinson's disease, gives us increased frequency, vivacity, and duration of dreaming, without effect on the frequency, intensity, and duration of REM sleep. It seems forebrain dopamine system plays a causal role in the generation of dreams, and it is really not the same as a cholinergic REM sleep system. Now, let's continue with ways dreams can be initiated independently of the brainstem's REM sleep. For example, Solms refers to the recurring nightmares during nocturnal seizures, which are mainly caused by seizure-like activity in the temporal lobe, which is total forebrain. The same anxious experiences, waking dreaming-like seizures, can be reproduced by stimulating this particular area artificially, while nightmares cease to exist after anticonvulsant therapy or temporal lobectomy. So, we have another forebrain mechanism. Solms provides us with much more evidence that shows how dreaming is related to cognitive processes. For example, dream deficits occur when high-order association areas are damaged, while damage to primary sensory cortices that would normally process raw brainstem data leave the dream imagery intact. But the main point the neuropsychanalyst would want us to take home is this: dreaming process is not synonymous with REM sleep, as it implicates many forebrain areas which seem to be crucial for both the generation of dreams and our mental lives. However, one might ask, then what about the high correlation of dreams and REM sleep mentioned earlier? How can we explain this? Well, Solms suggests a two-stage model. First, cerebral activation during sleep can occur through various paths, none of which is by itself specific to dreaming. That means REM sleep is just one of the many ways our brain can activate the regions that give birth to dreams, the most persistent probably, but still just one of them. And we proceed to stage 2, which is the activation of the final common path of both REM and non-REM ways, that is, the dopaminergic circuits and all the brain areas they further implicate. According to Solms, dreaming itself occurs only if and when the initial activation stage, whatever it is, engages these circuits. That means dreaming and their contents have much to do with our waking consciousness, our concerns, our desires, our anxieties, fears, or in general, our mental life. We are now able to see how different this model is from the one that ignores all the previously mentioned mechanisms, but REM sleep, and considers the forebrain the passive recipient of random data. The early observation that dreaming frequently co-occurs with REM sleep led the researchers to consider for a long time REM sleep the sole protagonist in the generation of dreams. Nowadays, 22 years after Solms' paper, the scientific landscape has undergone substantial change. As one could say, the view that dreaming and REM sleep are two dissociable states is now established, even though the previous belief that they are the same is still widespread in lay public. Many questions remain open regarding the neurobiology and psychology of dreams, in order to unveil how our brains come up with these spectacular imageries and their accompanying emotions, how physical and mental context affects them, how the elusive imprints affect us. One thing for sure, science says they matter. Thanks for watching.